Thanks, team. Those that are chatting, please don't chat. I just find it highly disrespectful. I'm trying to give you some examples so you can prepare, and then you might ask me these questions. And I don't like it when I'm trying to explain and you're wasted 8 minutes so far. Let's take 5 minutes off for preparation, though. All right, here we go. This is question 3 from Ex6IK. Now, 6I and 6K follow the same technique. They're both pretty much merged into one. They're split up into 2 sections. But the idea is the unit circle. So we start off, let's say, I don't know, just pick out F as an example, right? When they say cos of 210 degrees, there's 2 things that I'm looking for. Number 1, what does cos represent? It represents the x values. Okay, so that's one of the things that we knew from unit circle. We understand if I drew a unit circle on an xy axis, no matter which point you are on the circle, it will have, so from the radius to that point, it'll have an angle, where the angle always starts at 0, and we go anti-clockwise. Okay, we go anti-clockwise in the positive direction. And we know that at that point there is an x and a y coordinate. The length horizontally, well, highlighted here, the horizontal length actually represents the x coordinate, which also happens to be the adjacent side of this triangle. Because this is the adjacent side, it's cos A over h. Remember, radius of a unit circle is 1. That's why cos represents x values. So the first thing I look at when I see cos 210, I ask myself, there's 2 things there. 1, what am I looking at? Is it the x, the y, or is it the gradient? There's only 3 things there. X, y, x coordinate, y coordinate, or is it the gradient of the line? In this case, we know we're looking at the x values. Then the second part is positioning. Where am I on the unit circle? One of the big reasons why the senior levels we use radians is because the positioning is easier to figure out. At your level, you're likely only working within 2 revolutions. But in this case here, 210 degrees, if you ask yourself, where am I? What's the location? So there are only 2 things you got to figure out. What am I focusing on? And where's my location? Location 210 degrees. Now remember the quadrants go, quadrant 1 starts here, anti-clockwise 2, 3, 4. Where's 210 degrees landing me in? Which quadrant, Andrea? Quadrant 3, because we know all the way up to this point is 180 degrees. That's half a circle. And that means all the way down to 210 should be somewhere here. Because by 3/4 turn, that should be 270 degrees. So it must be 210 is somewhere there. Now, one of the first things I then figure out, so once we know the location, we look for the triangle. Where's the triangle that I've drawn? Well, at this point, it has an x length, which is here. That's your x length. And it has a y height for the triangle. And my radius is always 1. So this part, this is a right angle triangle that if I drew out, it actually just looks like this. Right angle triangle. That's my x, that's my y. Cos is talking about the x value. But already I can see this x value. What's one thing we know in quadrant 3 for cos? It's negative. And that's one of the questions in 6I. They'll just ask you, is it positive or is it negative or whatever it is. So in this case, I'm looking at that and I can say, yeah, clearly on a picture point, I don't even have to memorize ASTC. I'm just looking on a pictorial point. I can tell the x coordinate here must be negative. Same thing with the y. I can see that the y value is going to be a negative. So I know in that region, both y and x is negative. So that's why they say sine is negative, cos is negative. So I know the answer, cos of 210 should be negative. No matter how you do it, I'm already looking for a negative answer. So if this is a multiple choice question, I'm looking for negatives in any of the solutions. Second thing is they often ask you a reference angle. The reference angle means that the angles that you currently know, the angles that we know are 0, 30, 45, 60, 90. But later on you realize you don't actually need 0, 30, 45, 60, 90. It just means you're working within the first quadrant. So how do we know what the angle is? Well, I already know this. This is what I know. I have to go 180 degrees to get there. Then that little bit here in the triangle, I can actually work out because we said it's 210 in total, but that's up to here's 180, so what's left over? 30. And that could change. It could have been 260, for example. So if it was 260 degrees, then 260 take away 180 will give me that 70 degrees. So it doesn't have to be the special angles. The point is, what is the angle of the triangle you're drawing? Because once you get that right angle triangle, notice that in a unit circle, you can always draw that same triangle everywhere. So I can draw 30 degrees up. I can draw 30 degrees up on this side. I can draw 30 degrees down. All of them have the same triangle. And the benefit of a triangle is that all of them have the same x length and they all have the same y height. That's what we call symmetry properties. That's the name of what I'm teaching you right now. So 6K and 6I is under what we call symmetry properties. And all the questions are really just trying to get you to tell me, is it positive? Is it negative? Where's my location? What's the height? What's the length? What's the gradient? That's essentially what they're asking. Okay? So answering the question. When they say, give the exact value of the following sine of 210 degrees or cos of 210 degrees, they're asking, what is this length in quadrant 3? I already know it's negative, but you see, quadrant 3 has a triangle that's 30 degrees. Well, we then think back, your triangle when it's 30 degrees this way. So in quadrant 1, if I drew it up this way, same thing. 30 degrees this way. You get a triangle, and that length, when it's 30 degrees, should be the same length as this one. So what is cos of 30? And that's something that we do know from our exact values. That's saying I can figure out the length by finding cos of 30 degrees. So I may not have known 210, but based on the picture, I can tell that that 30-degree triangle can actually be replicated in quadrant 1. I just need to know the length. I know over here is the same length but negative. I just need to know the value. So now you go back to your exact values and how you memorized it, either the hand method or the triangles I've shown you. What is cos of 30? Root 3 over 2. So I know this length here is root 3 on 2. The only difference is, because it's in quadrant 3, it's root 3 on 2, but it's negative. So the answer is negative root 3 on 2. So you'll find that in your textbooks, they will do this bit. And that bit was find location, is it positive or negative? Find the reference angle. This is what they mean by reference angle. Okay? And then the value. Okay, that was a lot of explanation, but let's do another one just so you get a feel of it. Let's do tan. I do tan. Tan of 225 degrees. Was that right? Which one was that one? Yeah, 225. All right, let's try this one. Same thing. Two things that you've got to ask yourselves. One, what is tan representing? Andrea?
X over y.
Not x over y. Y over x, which is the gradient. Y over x means gradient. The gradient of a line, remember the gradient of a line has 4 types: positive, negative, 0, and undefined. Right? So I need to know unit circle. I'm interested in the gradient. Now the second part is location. Which quadrant is 225 degrees? 3. So I know I'm somewhere over here. Just pick that point there. It's 180 to go from here to here. So how much more do I need to get to 225? 45. Oh my God, I was surprised there. That's 45 degrees. Notice here I'm drawing my right angle triangle there. So I know this right angle triangle has 45 degrees, but I'm interested in the gradient. I'm not interested in the x length. I'm not interested in the y value. I'm interested in the gradient. Now, what can we say about that gradient? Just looking at the picture there. What gradient is that? Is that positive, negative, zero, or undefined? It's positive. From left to right, if it goes up, it's positive. But where else in this 4 quadrants can it also be positive? Quadrant 1, because if I extend the line, that's the same gradient. It's the same slope all the way. So I can draw the same triangle over here. They're exactly the same. So hence this is 45 degrees, has the same gradient, but we do know what tan of 45 is because we know they're going to be equal with each other. The gradient of tan of 225 is the same gradient equals tan of 45. That's what I'm saying. I'm saying the gradient here, so the gradient of 225 is the same gradient as 45 degrees. Okay? And the answer must then be 1. Because we said positive gradient. So quadrant 3, positive gradient. So the answer must be positive 1. Yeah. Wait. Shh. Team.
Because it's 10, it would seem like, would it just be 1 or negative 1 for all of them because that's the gradient?
That's exactly it. It's 1 or negative 1 if it's 45 degrees. So if it was 45 degrees in this region, then you're right. This would be gradient of negative 1. This one would be gradient of 1, and it's 45 this way. It's gradient of negative 1. That's it. So depending on what the angle is, knowing the exact value allows, yeah. All right, let's try another one. Let's see if you can do this quickly. Let's do L. See if you can do it in your head or if you can picture it. What is cos 300 degrees? So think positive or negative, which quadrant, and what's the reference angle? And knowing your exact values, you should be able to figure out the answer to this one. So which quadrant are we in? Quadrant 4, cos is positive, so the answer should be positive. And what's the reference angle? 60. Very good. And now you just got to figure out what cos of 60 is. Yep. 1/2. So draw the picture, if it helps. Quadrant 4, 300 degrees. That means this must be 60 degrees. So you got a triangle, reference angle of 60 degrees. And we can always draw that same triangle up here. Yeah. Cos 300 degrees, so all the way up to here is 300. You only need another 60 to make 360. Because one revolution is 360 degrees. Oh, you're talking about this side. Yeah, you can do it this way. It's a bit more confusing though. You can do 30 degrees this way. But then you're starting from here. You're saying 270 plus 30. And so you can have a triangle that looks like this. But you see, this is not cos anymore. This is the opposite side. So that will be sine of 30 will tell you the cos. Because remember, the question's asking cos of 300 degrees. So if I draw the triangle again, so 300 degrees. See, it's asking for how far. So this is 60 degrees. That's cos length. But if you did the 30 degrees, it works. But the 30 degrees is your sine. So if you did sine of 30, that should equal to cos of 60. Because you're looking for horizontal length. It's easier to work from the x-axis, yeah. If you work from there, cut down, or from here down, or from here up, it's easier. You can do it from here, but that's like a high level thinking. That's a property that students haven't taught you guys that. It's called further symmetry properties. But you can do it from the vertical axis. So you go from here out 60 or 30, and this one down 60. So that works too. But That one's harder to think about because you have to switch the sine and the cosine. It gets a bit more confusing. Yeah. All right. Do we feel a bit more confident with that? Yeah. All right. Let's try. Back to 6i now. Thanks, team. All right. 6i. You should find 6i a bit easier now. Thanks on the back right corner. Raph. Thanks. Ex6IK now should feel a bit easier because it's now looking at things like the macros or the micro steps. So it'll be asking you, is it positive or negative? So for example, if you picked this one, at 154 degrees is sine positive, cos positive, or tan positive? Yeah, you mentioned, is it positive, negative, positive, negative? Okay, so this is training you to think about the unit circle. Which quadrant are you in at 154 degrees? It is? Quadrant 2. So in quadrant 2, if you picture it, quadrant 2 is over here. X value is clearly negative. Y value is clearly positive. So sine is positive, cos is negative, and tan must be? What's tan? Quadrant 2. Is that negative or positive? Negative. Because we've got y over x, but if y is positive and x is negative, you get a negative gradient. Okay? Let's try another one. What about question 4? Thanks, team. I prefer no chatter while I'm explaining this. Question 4, write each of the following using its reference angle. This is pretty much what I was just showing you just now. So let's do cos of 294. So this is not necessarily using exact values, but you just need to know where would I find my reference angle? What would it be referenced to? Yes, Una.
I've got a question.
Oh, yeah.
From the ones before,
Yep.
when you put on a calculator, why do all of them have a relation to 5?
To 5?
Yeah, like cos of 300 equals to cos of 60. You get 300 divided by 60, you get 5. Like, with all of the questions.
I think all the questions that we had before were exact values. So there will be multiples of 30, 60, 45 to fit in our circle. But it wouldn't work for this one.
So for those ones, would all of them have a relation? So would all questions that have an answer of a whole number, do they all have a relation?
I think it's only 30, 60, 90. Yeah, I don't think all whole numbers. You could try 70 and it shouldn't work. Yeah, if you did cos of 70 or like multiples of 70, it shouldn't be related to a multiple divisible by 5. I think that's what you're asking. All right, let's have a look at reference angle for cos 294 degrees. Reference angle, again, find your position. We're clearly in quadrant 4. Now 294 degrees is this way. How much more do I need? What's the missing angle? Oh, yeah. Yeah, I see what you're doing. So I was asking for reference angle. So 66 is missing. This is my right angle triangle. Reference angle is this one. The 66 in your triangle. So that is equivalent to finding, if you drew that length, cos is the x length, it's the same one if you found in quadrant 1, x length of 66 degrees will be the same. So if you typed on your calculator cos of 294, instead of finding the x length of 294, you can actually find the same x length for 66 degrees because you're looking for that triangle. So the triangle needs to be the same. Okay? I'm going to pause there because I'm not sure how many of you are actually following, and then some of you really know the stuff, and then some of you look very lost as well. So maybe I'm just going to go individually for those who are totally lost on this concept and is like zoned out, and then the rest who seem to know their stuff, you could then do your stuff. Yeah. But that's one of the problems when I'm going through things. If you're not listening, then you fall behind. Then you have like a variety of students. You've got students who have no clue what I'm saying, some kids who totally understand everything I'm saying, and then some kids are kind of switching in and out. And so in order to, that's why I always say, like, as I'm going through it, listen, write some notes, and then when I explain it later, it makes more sense. Otherwise, I'm always chasing 3 different groups of students. Okay? It is your exam revision, so I do want to give that time to you. Remember, Monday, I'm not going to be explaining anything. I'll just be walking around to see if I can help. That is your session before the actual exam day. Today, I spent, about 23 minutes explaining things for you guys there. But hopefully that gives you more direction to work on Ex6IK. This is your time now. I'm going to stop the video, and then I'll come around.